All right, so let's take a look at this next problem. We're working with parabolas. They want five pieces of information. They want us to rewrite this equation in standard form, and then to identify the coordinates of the vertex, to find the value of p, to um, find the equations of our two lines, our axis of symmetry, our directrix, and also find a point that they call the focus. Um, we know this is a parabola because it's x that's being squared and not y. So let's jump in and rewrite this in standard form. I'm going to keep the x's on the left-hand side of the equation, and I'm going to rewrite, um, I'm going to move these other terms that are not x, that do not contain an x, to the other side of the equation. So I'm going to add 2y to both sides, and I'm going to subtract this 1.75. So now to complete the square, we look at the coefficient in front of this linear term, this 5. We take half of 5, 5 halves. We square that. That's 25 over 4. 25 divided by 4. Let's 6.25, probably. Let's see. 2.5. 25 squared is 625. 2.5. Yeah, 6.25. If I add that to the left-hand side, I need to balance the equation and add the same amount to the right-hand side. On the left-hand side, it's 3 terms. The reason we added that amount is so that we can, that it's a perfect trinomial, that it's a perfect square, and that we can factor this to x plus 5 halves. I'm going to write 5 halves as 2.5. That's being squared. On the right-hand side, we have 2y plus 625 minus 175, 625 minus $1.75, 450, 4.5. Let's factor a 2 out because we need this coefficient in front of the y variable to be a 1. So I've got x plus 2.5 quantity squared is equal to, if I factor this out, y plus, and that 4.5 is 9 halves, and if I take half of that, that's 9 fourths. And if I take 9 divided by 4, what we get, the 2.25, I think. 2 1/4. All right, so now we've got this in standard form. Let's identify the coordinates of the vertex. Negative 2.5, comma, negative 2.25. Take 4p and set it equal to the coefficient in front of y. Divide both sides by 4. Just recognize that half of 4 is 2 and that p has to be 1/2. It's the x that was being squared, so therefore it opens up or down. Since p is positive, the parabola opens upward. We're interested in the point that they call the vertex that's on the parabola. We're interested in a line that passes through that vertex that's referred to as the axis of symmetry, because this parabola, the left-hand side and right-hand side, are mirror images of each other. This vertex, we found it as a decimal number. And check my arithmetic. I'm not always the greatest at this mental arithmetic. The x-coordinate, negative x equals negative 2.5 is the axis of symmetry. Our focus is always inside of our parabola. The focus is p units away from the vertex. There's another line that's perpendicular to the axis of symmetry that's called the directrix. It is also p units away from the vertex. So let's look at this as 1/2. So if we're 1/2 of a unit up and we're 1/2 of a unit down, we're changing the y coordinate on this vertex. So if I go down 0.5, then this directrix is y equals negative 2.75. If I go up 0.5 units, then the coordinates of this focus is negative 2.5 and negative 1.75, wouldn't it be? Yeah, I think so. All right, so I think I have all the information that they wanted. I rewrote the equation in standard form. From that standard form, we identified the coordinates of the vertex. We identified we determined the value of p. P helped us because since it was positive, the graph opened upward because it only had x squared. The magnitude of p helped us. If you're p units away from the vertex, you'll either be at the focus or at the directrix. If we went 1/2 of a unit up, that changed the y coordinate and we were at the focus. If we went 1/2 a unit down, then that point that's the intersection of the axis of symmetry and the directrix, why that point was on the line, y equals negative 2.75. So we found everything, and I hope that helps. I will talk to you later.